Hello, so we're going to have a look at binary subtraction. The basics are, of course, like base 10. 1 take away 0 is 1, of course. 1 take away 1 is 0. But we sometimes run into problems when we have 0 in the top number, take away 1 in the bottom. So like with base 10, we just need to borrow or exchange to continue. So it's important to know your binary column values and what they're each worth. So of course we have the units 2s, 4s, 8s, 16s and 32s, etc. This is a 1, 2, 3, 4, 5, 6-bit length place value table. And it's really important to remember that a 1 in any column is worth 2 in the column next to it. So if we have a 1 in the 16s column, if we change that, we could change it into 2 8s in the column next to it, obviously because 16 is 2 lots of 8 and so on. A 1 in the 2s column is worth 2 1s, but we're not allowed to put the digit 2 in binary, so we could write it as 1 plus 1. So let's have a look at some examples. This one's very straightforward. 0 take away 0 is 0. No sweat there. 1 take away 1 is also 0. And then we have left over 1 and 1. So in this example, we have 0 take away 0. Nice and easy. But here we have 0 take away 1. And I'll just put the columns up because it's the first one where we're going to exchange. So what we can say, instead of having a 0 here, we could change this 4, or we can change the 1 there, so we've got no 4s left. Change one of the 4s into 2 2s, because 4 is 2 lots of 2. But because we're not technically allowed to write the number 2 in binary, the new number on the top here, I'm going to put as 1 plus 1. So all I did, I changed a 1 in the column to the left into 2 on the column to the right. And now we have 1 plus 1, obviously 2, take away 1 is 1. We have nothing left in the 4s column, but there's nothing to take away. And then we have 8 take away nothing. So example C, we have 16 take away 1. Or 1 0 0 0 0 take away 1, and it's easy to do in base 10. Of course, we're expecting 15 as the result, but the method is that we're going to take 1 away from 0, and we can't. So we look to the next column. There's nothing there. We look to the next, and there's nothing to exchange. So we need to go right over to the next non-zero number in the top number. We need to change that 1 so it doesn't exist anymore into 2 of the next column, because 116 is worth 2 8s, but that still doesn't help us down on the right hand side. So we're going to take one of those 8s, so that's gone, and that is worth 2 lots of 4. Then we're going to take one of those 4s, and it's worth 2 lots of 2. And we're going to take one of those 2s, and that is worth 2 lots of 1. So now we can get going. We've got 2 take away 1 is 1. Now we've got 1 take away 0. Because there's only 1 left now in the 2s column, because we changed the other one into 2 1s. 1 take away 0 is 1. 1 4 take away no 4s is 1 4. 1 8 take away 0 8s is 1 8. And here there's nothing, there's no 16s anyway. So the answer is 1 1 1 1, which definitely is 15 in base 10. So that's how we exchange in binary subtraction. And I hope that you found that useful. So have a go at some yourselves.